folks. Good morning. Wednesday. Whatever today is, the 13th. Today. All right, we are going to get right into it because I want to make sure we cover the web vulnerability. To go, basically. So we're going to pick up right where we left off on Monday. So we looked at. We've now seen up to this point, we've seen web applications, we've seen some server-side web technologies like PHP. Now we need to look at how do we store state on our web application. And we saw that a lot of times this state is really a database, and one of the most prominent ways of how to query and interact with the database is through SQL, which is the structured query language. So it's essentially a special purpose database, or special purpose language to interact with a relational database. There are multiple commands. The ones that are really important are select, which fetches data from the database, update, which allows us to change data that's stored in the database, insert, which allows us to put new data in the database, and delete, which is the other one. There are sometimes slight differences between SQL implementations. Every database engine has its own, basically, what's the word I'm looking for? Dialect of SQL, that's what I meant. Dialect, yeah. Its own dialect of SQL. So there are some variations between them. So some examples, so this is a query, so select all columns, the stars columns, from the table users where the username is equal to Adam. Select all the columns from book where price is greater than 100.00 and order by title. This is select the ISBN number, the title, the price from the book table where price is less than the average price of the book. So this is all of the books that are less than the average price, order by title. We can insert into there. So here we specify the table that we want to insert to, which is example, and we say we want columns field 1, field 2, field 3 to have the values test and a null. Update, we can say update example table, set field 1 equal to updated value where field 2 is equal to n. And then we can also, so SQL also allows us the ability to combine the results of two queries together. So here, this is what's called a union query. So we're basically going to take the first query and put it together with the results from the second query and return that in one result. So we're going to get all of the A's from table 1, where A is 10 and B is 1. We'll get 10 of those, and we will add to that all of the A's from table 2, where A is 11 and B is 2. So this allows us to extract information from different tables in a programmatic way. So let's look at how PHP issues SQL queries. So this is from the PHP manual. So you first connect to the MySQL server, passing the user and the password. If there's an error, you stop and say, hey, I can't go any further. You select whatever database you want to use. And then let's say you have some first name and last name. This is a real example. I mean, real from their documentation. Then you do a query by doing an sprintf. So we're going to select first, last name, address, age from friends, where first name is single quote %s and last name is single quote %s and single quote first name, last name. So what's sprintf doing? What's the result of this going to be?
Printing the output.
What was that?
Printing the combined output.
Building, what do you mean the combined output?
Printing it.
Printing it where? Into the query variable, into a string. Yeah, that's the S. So it actually hasn't touched the database yet at this point, right? All we have is a query string, and this %s is replaced by the first parameter, and this %s is replaced by the second printf parameter. I actually just thought about it. I don't think I've looked at it, but I'm pretty sure PHP's printf functions do not support %n, because that would be silly. But if anybody looks, that would be kind of cool to find out. And what happens if we pass more parameters than our parameters here? Okay, so at this point, so if we're to talk about where could vulnerabilities exist, right? At this point, there's no vulnerability. All we have is a string in the variable query that happens to be a SQL query, right? If this variable never touch, if this doesn't get passed to a database, if it gets output to the user, right? There's no, it's just a value in memory. How we issue this query is we use this MySQL_query function to issue this SQL query to the database. And then if there's not a result, we say that there's some error. Otherwise, we use other functions like MySQL fetch association, which fetches each of the resulting rows from this query as an associative PHP array and sets it into that variable row so we can access things like row first name, row last name. And we know we can access row first name and row first name and row address because of this here. Okay, questions on this? So this gets back to some of the PHP things, these MySQL functions, they're just global functions, that's why they all have MySQL_ prefix there. MySQL query is the actual function that talks to the database. Any other questions? Cool. Okay, so this is our little primer on SQL. We will come back to this when we need to talk about SQL injection vulnerabilities. Okay. So, we saw the original HTML, right, has images, tables, you can actually do font sizes, it has a lot of other things. But fundamentally, right, anybody remember browsing the web in like the late 90s, early 2000s? Is it anything like it is now? And what's the big difference?
Frames.
What was it?
It used to use frames
You used to use frames for what?
for dividing the page.
For dividing the page, yeah, so you could have frames are actually a huge pain. Actually, do not like frames. But what did that, so you can use that to divide the page. Was there a lot of, how would a web page change? Yeah, so you click a link and then you'd see a new page, right? And the page would change. But when you're looking at a page, the page would not change, right? Almost, I would say 99% of the content was static, right? You get a page and everything just looks static. And actually, if we go back and look at some of the home pages, so this is Yahoo's homepage from 1996. So we can see it's just a page with links on this page, right? And yeah, there's an image up top, there's a search bar, whose search was terrible, by the way. There's what? Oh, there's we have Amazon's homepage, one of the early, when Amazon launched in 1995. Now it's kind of weird to think about now that Amazon was not in the cloud services business, right? They were just sold books. This is all they did was books. And look at the page, right? It's just static page with links on the page to get you to click on things. This is Alta Vista from 1996, also static page. And even, although actually I'd say, I guess it hasn't changed very much. So from 1998, Google's homepage, or actually even before that, it was called Backrub, was the name of their search engine. So this was the early Google homepage, right? And even this, although I guess I'd say it's actually very similar today, right? We have the Google search button and the I'm feeling lucky button. Just kind of crazy. Okay. So HTML was originally created, right, to describe a text document with hyperlinks to other text documents, right? This is the basis of HTML was we need a language to describe these hypertext documents. But as the web took off and as maybe you could argue as non-nerdy, non-technical people started to use and interact with the web, they thought, well, hey, but how do I make like fancy animations or pretty web pages, right? How do I actually make something that looks nice and doesn't just make me want to like throw up and never shop at this place ever again? Sorry, I know some of you are going to work at Amazon, but it's a good historical thing, right? So that's when this is really where JavaScript came in. So we think of now as this like JavaScript, this cool programming language of the web. You can run JavaScript on the server, do all this crazy stuff. But it just started to solve this simple problem of, man, we wish web applications did, or web pages did fancier animations and were prettier. And so JavaScript is fundamentally a client-side scripting language for interacting and manipulating HTML pages. And that's really the genesis of JavaScript. It was created by one person at Netscape, Brendan Each. Actually, I don't know how to pronounce that name. Sorry, Each. In 1995, and I don't think I have it here. I think he developed it in something like a week or 2 weeks. He was on a huge time crunch because Netscape wanted to get this out to show that they could do something like this. And it's actually really funny to think about names, right? So he created it as LiveScript, which actually is kind of cool. It's a decent name, right? Netscape changed it to JavaScript. Anybody know why they changed it to JavaScript?
Popularity of Java.
What was that?
The
You were in my class. You don't get an answer. Yeah.
So prior to this, there was some another similar thing developed by a person which she called as Hot Java, and when Hot Java wanted to make it official, like they wanted to make their language official, these guys went to the conference at Europe somewhere, and they got it named to JavaScript, and most of the functions that they have been defined have been taken from Java, like for example math and all those things, because the Hot Java was primarily developed by a Java developer.
Interesting. Okay, I had not heard that story. So from the press release, so they say that they're announcing JavaScript, an open cross-platform object scripting language for the creation and customization of applications on enterprise networks and the internet. Really good copy for whoever wrote that. And JavaScript from Wikipedia, it says that it's a prototype-based scripting language with dynamic typing and first-class functions. Does this sound anything like Java, especially the Java of 95? Is Java a prototype-based language? Is Java a scripting language? Does Java have dynamic typing? Does Java have first-class functions? Not really, right? So actually there are some questions over why the name to Java. Some people feel that it was a marketing ploy to try to because Java, believe it or not, at the time was like write once, deploy everywhere. It was the hot programming language. Like everybody was talking about Java. It had a huge buzz. So one of the theories is that they changed the name to take advantage of this buzz and basically piggyback on that. There's some collaboration between Sun and Netscape, so maybe somebody there was like, hey, you should call it something like Java. And so after this, in 1986, Microsoft added support for JavaScript to Internet Explorer. And there's this whole weird thing where Microsoft changed the name of their language to JScript. So that way they wouldn't use, because Sun had a trademark on the name Java in programming languages, so they didn't want to call their thing JavaScript. Finally, this kind of all got settled a little bit when it was submitted to the ECMA, the International Standardization Body, which was finally standard as ECMAScript. So this is kind of like the classic traditional version. If you have a reference to that story, please send it to me.
Yeah, sure.
So I'd like to include that. That's really interesting. So JavaScript, love it, hate it, don't care about it. Whatever your feelings, it is the language of the web, right? Every single browser, every single device now supports JavaScript. And so that it just is. We can't really change it, although we're trying to move in that direction. It's eventually supported by all browsers, and it evolved organically along the way from the original 1995 creation. And so to look at how kind of mechanically how this works is basically the idea was you embed your code into your HTML page. So instead of just having a document that describes links and images and just basic text, you can actually specify to the browser, hey, here's some code, execute this code for me on your browser. That seemed like good from a security point of view. That seems crazy, right? Yeah, here, browse my page, execute this code, right? How this looks, so inside of script tags, So start script tag and ending script tag. This is the way for the application developer to tell the browser, start executing JavaScript. So inside these script tags is my JavaScript code. And it used to be that not all browsers supported JavaScript, so you would actually have to put your JavaScript code inside an HTML comment because other browsers that didn't support JavaScript wouldn't show it. And so you could actually be backwards compatible in this sense. So we can do things like we can declare a variable called name, which is the result of calling some built-in function prompt, and we can pass in values here. We can say if name is null, then we can write welcome to my site. Otherwise, we can write out welcome to my site plus the name. There are one other way, or there's other ways to do this. The default for a script tag is JavaScript. You can also specify the language in either the type attribute or the language attribute of the HTML tag. And so if we run this or if we access a web page with this script tag, it'll look something like this. We'll go to a page, and it'll pop up a prompt. This asks us to please enter our name. We'll type in something. If we click OK, then we can click Adam, and it'll say, welcome to my site, Adam. Right? So here we're actually building, and remember, none of this made any request back to the server. Right? This is all happening on the user's browser without any external requests. So here we have code that's executing and dynamically changing the HTML of the page based on the results of this code. That's kind of the core of JavaScript. Is it's running on your browser, and it can change the content of your page. And so, so including JavaScript directly into every HTML page is kind of a pain, right? It's not the best practice from a software engineering standpoint, right? You have to duplicate your code everywhere that it's used, right? And so you can include JavaScript files, external JavaScript files in your HTML. So the previous one we saw is called inline JavaScript. So the JavaScript code is inline in the browser page, whereas these are external. So the idea is, once again, you use the script tags, but here you set the source attribute to be either an absolute or a relative URL. And what happens is when the browser parses this element, it automatically fetches and executes that JavaScript before continuing to parse the rest of the HTML. And it's semantically equivalent, so it's exactly the same thing as if you took the contents of that JavaScript, whatever the result of making an HTTP request to that URL, and putting it directly in the page there. So scoping rules, whatever, it still has the exact semantics there. And so there's something important to keep in your mind. So yes, JavaScript is the basis, the history is a language to interact with HTML pages, right? But that doesn't mean that, but there is a separation between the language JavaScript and how JavaScript interacts with the HTML page, right? Similarly to maybe PHP is usually used to generate HTML pages and used as a web application, but you can actually use PHP as a command line tool if you're crazy. It doesn't have to actually output a web page, right? And so the document object model is a way to separate out from JavaScript. Okay, this is all the functions of JavaScript that deal with how to interact with the HTML document on the page, which is separate from the language itself. So a lot of people, even people who've done JavaScript for a long time, often conflate these two ideas. And now it's being even more important with being able to run JavaScript on the server to be able to tease out these ideas. So the document object model is a programmatic, it's an API to manipulate the client-side content. And there's a globally accessible JavaScript object called document. And this is how you, by interacting with this object, is how you access and change the HTML content of the page. So you can traverse, query, manipulate, and change the browser's representation of the HTML page, as well as set event handlers that say things like, when the user clicks on this button, execute this JavaScript code. So DOM0 was released in 1995. It was incredibly basic. These kind of kept improving. The W3C stepped in and started to define standards. It's now a living standard, so it's continually evolving based on website developers and browser vendors. So let's look at an example. So here we have our HTML page. This is a valid HTML5 page. Here we have an H1 tag, a header tag that's a DOM example, and inside there is a div tag that has an ID of insert here. And so we have some super simple JavaScript code at the end here that first is going to create, so we know it's using the DOM, so it's calling the document object. It's going to create an HR element. What's HR? Horizontal rule. Yeah, so it's just going to be a line. We're going to set that new element to be HR, to be in this variable HR. But notice we haven't done anything with it. We've just created this element, but we haven't put it anywhere in the DOM. So if you do this, it will create this element, but it's not going to do anything with it. So what we can do is we can access the DOM and we can say, okay, document.find an HTML element that has the ID attribute of insert underscore here, which is going to be this div right here, and add as a child this HR element. So this is exactly identical as, once this code runs, it will be identical as if there was in between this div tag, right? Inside there as a child will be an HR tag. And so we can look at this and we can go, yes, if we execute and run this, we'll see DOM example as the header and we'll see a line where that line actually came from the JavaScript code that executed. So this is how JavaScript is able to interact and change. And this is the fundamental mechanism that all of the fancy web applications change and manipulate your content of your page. Okay. So part of the problem is you would think that, well, we have this DOM, we have this nice programmatic interface, we can just use this to do whatever we want. It turns out that browsers are horrible and the web is horrible and everything sucks because every browser has slightly different ways of accessing or different semantics of accessing the DOM. Like it's not quite the unified standard that we would all want and love. So some highlights from this awesome Stack Overflow question of what cross-browser issues. Internet Explorer does not replace ampersand NBSP. So this would be NBSP is non-breaking space. Or HTML character code 160, you need to replace its Unicode equivalent. So Internet Explorer for some reason has a bug or whatever that it does not do this. So you would have to do this yourself. In Firefox, and this is not to bash on any one particular browser, right? They're all terrible. In Firefox, a dynamically created input field inside a form created using document.createElement, not when you create it in the HTML, does not pass its value on form submit. What? Document.getElementById in Internet Explorer will return an element even if the element name matches. So if there's a name attribute on a tag, it will return that, which is not what you would expect would happen in a function called getElementById, not getElementById and also name. Mozilla will only return the element if the ID matches. What? That's crazy. So this is why, if you've ever done web programming, you've probably faced these issues, or maybe you were smart and just started using jQuery from the start. So this is why jQuery is so popular, because it provides a uniform interface and it handles all these low-level details of cross-browser compatibility. So you don't have to worry, you don't have to stress about checking if you're using Internet Explorer and will getElementById actually return what you want it to return. jQuery will completely take care of that for you. Cool. I guess I should ask, have you done JavaScript programming work? Decent amount. jQuery among those? A good amount? Yeah, probably. It's almost like if you're doing the web and you're doing JavaScript, that's something that's longer than even 1 or 2 lines, you'd probably still want to use some jQuery because you're probably going to do it wrong for some fraction of browsers, and there'll be really weird problems. Okay, so the document object model is all about how do we access the HTML of the page, right? Or essentially, or how do we modify and interact with the content of the page. In contrast, the browser object model allows in JavaScript to interact with the actual browser itself, right? So this doesn't have to do anything with the document, but this is things outside of that. And of course, because it's the web, there is no standard of what is standard for the browser object model. And even this term, browser object model, is colloquial. It's not a standard term. So some examples, you can set the name of your tab or your window to be new name by using window.name. Right? So this has nothing to do with the content on the page, right? You're just changing the title of the HTML page in the browser. You can close, right? So you can have your, I actually don't know how you do it nowadays on a tabbed environment. Does it go away automatically? I have to check, but it used to be, so JavaScript code can just close that page that it's on. We can actually do essentially a redirect within JavaScript here by setting the location. So the location would be the location bar to be a new HTTP URL. And the browser will automatically go there to that location, just as if we were redirected there by the browser. So we can do this all in JavaScript. Okay. So just to reiterate, JavaScript, the language, is different from the document object model and the browser object model. DOM has its own specification. The BOM is kind of specified in HTML5. They're used together so much, but with JavaScript occurring everywhere, it is important to separate these in your mind, right? We have server-side code in Node.js. You can use JavaScript to specify database queries in a framework, or I don't know what the best way to call that, but in MongoDB, right? So you actually can query, instead of using SQL to query, you use JavaScript to query. Flash, action script in Flash is actually essentially JavaScript, but kind of different, and it has its own DOM-like capabilities to manipulate Flash objects. Even Java applications, you can use javax.script to script your Java applications. Windows applications, this is the name, the Windows RT, that's right. Right, so you can write Windows applications now that are, I'm sure there's some maybe OS functionality, maybe it would read-write files or something like that, right? That doesn't make sense in a web context, even though it's still JavaScript. Okay, so now we're going to kind of dig in a little bit more into JavaScript, the language, to see how weird things can get. So Java is object-based, which means almost everything is an object. And objects are essentially associative arrays or hash tables, so key values. And properties and values can be added and deleted at runtime. So these are not the traditional objects you think about when you think of classes and objects, right? Where classes, the fields are defined statically based on the definition of the class, and the methods are also defined statically. These are all done at runtime. So for instance, here I have a variable, so the var keyword defines a local variable that says the name of this variable is object, and it is this object has one field called test, which value is the string foo, and one field called num, whose value is an integer 50. And they can do crazy things like set object bracket test, so a foo is equal to object. So here I'm creating a new field in this object foo, which contains the object itself. And I can write out object test. So what's this going to do? Yeah, so object test is going to look in here and return foo. And, well, actually, object foo is what? The object itself. So it's going to, and it's going to, JavaScript has automatic corrosion, so it's going to try to, if we ever try to use an object as a string, it will try to call the toString method on that object to try to turn it into a string. So this will automatically print out whatever this object itself is. And then we can do things like set, so this is the other type of syntax, so we can access fields in objects with the bracket array, bracket notation. we can also do it with the dot notation. So we can say object.num means access the num field of object, set it to be 1000, and log that. Right? So these are going to reference the same field. It's actually exactly the same. And so we can do this. So we can see here we've done the variable object. We say object foo is object. And the browser, so this is inside the browser's development console where we're doing all this. And then when we do object.log, right here we see it's, wait, what's actually outputting? Oh, it's logging it, right, it's right here, yeah. It's outputting the object here. We set object num equals to 1000, and we log object angle brackets num to be 1000 as well. Okay, so other things about JavaScript. So we can do recursion in JavaScript. So we have a function factorial, and we can set if n is triple equal to 0, we return 1. Why, JavaScript people, why are we using triple equals here?
Because type coercion.
Yeah, because it's also terrible in that, actually PHP does this too, so I'll say like 80% of the languages web developers use are terrible. So if we just use a double equal sign, JavaScript will try to turn n into an integer if it can. So it's a string. If you pass in the string 0, it will double equals the integer 0, which is could be what you want, but 9 times out of 10 is not exactly what you want because that doesn't make sense. So use triple equal sign and say, are they the same thing and the same type, basically. And then we're going to turn n times factorial of n minus 1. So we can do things, we can log factorial of 5, and that'll tell us that it's 120. So we can do this. But JavaScript actually, so the first class functions gives us a lot of really cool features. So we can actually have anonymous functions. So these are functions with no name. And we can create closures over those functions. So we can return functions from a function that refer to local variables in the scope of that function. So to look at what we're talking about, we can, so this is, so we saw the syntax here for defining a function. So this defines a function named factorial. What this is doing is, on the right-hand side of this equal sign, is it is creating an anonymous function. This function has no name. It is setting that anonymous function to the variable createFunction. And functions are objects in JavaScript, just like everything else, so you can call them, and you can also access fields of that function. So in here, we can set some variable we count, and we can actually return from this function a new function, which returns ++ count. Right? So this is returning, so this function createFunction actually returns itself a new function, and that function that it returns refers to this variable count. So we can do things like we create a function called inc, an incrementer function, and we can call inc, which is this function in here. So that's going to be, so now the count of what it's going to return is, oh, forgot the difference between ++ before and afterwards. It's a prefix, so it's going to use it and then increment it. Is that right? Okay, good. That's why these operators are terrible. Use and then increment, right? Or no, increment and then use. Cool. Okay. So this is going to output 1. This will output 2. This will output 3. But we can create a brand new function, an incrementer 2. And now what's this going to output? What's this going to return? 1, right? Exactly, because there's a new count variable. So this inner anonymous function closes over this count variable. And so every time it's executed, that variable from that scope is being incremented. But here when we create a new function, it creates a new variable count. So the new function refers to actually a different instance of this variable count. Cool. And we can see this in action. Do we say it right? Yes, we did. Cool. So we can define this function. We can say that increment is a new create function. We call it, it returns 1, 2, 3. And then we call a new create function and it returns 1. Does actually really fun if you ever want to play with this. Highly recommend it. Okay. JavaScript also has features, and PHP has this as well, to do runtime evaluation. It's used a lot more in JavaScript. So the idea is the eval function or set timeout or set interval, all of these functions will take a string as their argument and will interpret that string as JavaScript code and execute that JavaScript code contained in that string. Also exec script. So we can have a variable foo is equal to bar, and we can eval a constant string, right? Where it'll say foo is equal to Adam. And now if we print out the value of foo, what's it going to print out? Adam. Is this very easy then to reason about what code is doing that has an eval in it? Oh, it can completely change and do anything, right? What if this string came from the user? Probably not great, right? Even then, we don't know what it's going to do. It could do anything, right? We can even have a variable x, so we can have console.log hello. We can set that to be some new function x, and then when we call this function test, this is going to parse this variable, even x is a string. It's going to take that string as if it was a function definition, and then it's going to call that function and execute that code inside that string. So we can see here, we have foo is a bar, we eval that, it's going to, and when we log foo, it's going to say Adam, and here, when we call this function test, it's going to say hello. So here's all different cases where we can actually turn this into, we can turn strings into code, actually. Okay, so some of the actually classic use cases of JavaScript, and to try to get you some feeling that it's not superfluous, right? So JavaScript actually has a very important purpose on the web, even without thinking about fancy animations and graphics and jQuery and Ajax applications. The question is, so you're writing a web application, how do you validate the user input that the user gives to your application? It's a real question. How would you do it? You're writing an application. So no JavaScript.
Parse it.
What was that?
Parse it.
Parser? Where?
Like
So
parse
the
it to
plan set.
find if there is anything.
Yeah, you need to validate the input, but where do you do that? The server, right? The user has their browser, they fill in some values, they hit enter, and then it goes to your server, then you can check it, and then you tell them, hey, those values didn't pass my parsing, right? That's not actually an email address you sent me, right? But this requires a round trip to the server, right? The server has to be able to check that the input is valid, right? So a classic example of this would be we check if there's a submit, then we get this thing from the student, we set a student variable, we set a class variable based on the get parameters, we get the grade, we check, right? We're doing some validation, making sure that student's not empty, class is not empty, or grade is not empty. Otherwise we say, hey, there was an error. Otherwise, if the grade is one of the proper things, right? We say, hey, there's an error, your grade has to be one of these. Then we say, otherwise we say grade successfully submitted. So here in the form, right? The form has a named student, a named class, a named grade, and we know that because the form does not have an action attribute, it's going to submit to the same page, default over a GET request. So if we have our form here, we can fill in Adam D, grade A, but we didn't fill in a class. So we're going to do this, right? It's going to make the request to the server, and it's going to say, error, you didn't fill out all of this form. Right? So I can fill out something in there, but change the grade to be a G, and it will tell me, well, actually the grade has to be one of these values, right? This is classic, basically, input validation that you all do when you write any kind of application, right? Because users are terrible, they can put in whatever they want, right? So we need to make sure what they put in makes sense. All right, then I can finally submit it. But if we think about what just happened in that context, right, of me typing things in, what had happened was my browser made a request to the form validation PHP page, got the response, the initial page, and then it made another request with an empty class field, and I got a response saying, oh, I need a class field. I made another response with the wrong grade format, And then I finally got another response back saying, oh, that's the wrong grade format. And then finally I had a correct submission. So this caused what, 1, 2, 3, 4 round trips to the server. But we saw with TCP, if I'm not keeping this connection open, which doesn't necessarily always happen, right? This is going to be 4 three-way handshakes in order to establish the connections there, right? This is hugely inefficient just to know that, well, you really wanted me to put in the class field and the grade has a specific format, right? So what we can use, and one of the use cases of JavaScript is to do this validation on the client, right? So we can have our form and we can have JavaScript here. So the key thing here is that we have an onSubmit handler. This handler says, essentially run this JavaScript code of return the check function, a check form function. And if that returns true, let them submit. If it returns false, stop them from submitting. And so inside that function, assuming that's defined above this use here, we can define some check form and we can say, hey, get this form. So use the get element by ID, get this form on this page. And if the values are empty, then pop up an alert to the user that says, hey, you must fill out all the form and return false. Test the grade. Say, hey, the grade has to be one of these. Otherwise, return true. So now, stepping through our other example, right, we fill in a student without a grade, and it pops up an error message immediately, right? The JavaScript code does this automatically right when we click that button. The JavaScript code is living, running on the browser on our machine. It checks and then it pops up this window. And then we say, oh, okay, well, change the class and change the grade. Well, then it pops up again that, hey, the grade wasn't right. And then finally I can change that and successfully submit it. And now it actually makes the request to the server. Right? So now I've gone from here to just correct submission. Right? So I've cut out all those middle parts. Okay. So if we do this, right, if we're doing this on the client, right, we're checking, making sure that the input's correct, then can we get rid of all that code in the PHP side? Right? Because the less code we have, the less bugs we're going to have, right? So we've already done that check in the JavaScript code. Can't we just get rid of that on the server-side code? No, why not?
The user can switch off the JavaScript.
Yeah, the users can disable JavaScript, right? There's nothing that tells us that the user actually went through and the JavaScript code verified that everything is in order, right? The user could disable JavaScript. We explored in one of the assignments command line clients, right? They're definitely not, they're just making HTTP requests. And from the HTML of this page, right, we can know exactly what request is going to be made when this form is filled out. We know this is making a GET request to the same page with a name of student with whatever value is, a name of grade with whatever value is, and a submit. So we can actually automatically create an HTTP request directly from this. We don't need a browser at all. And so this actually can lead, we'll look at it later because we're going over the groundwork here, but this can lead to security compromises depending on what the validation does. So this actually is a problem, right? Because now the validation must exist on your server side and your client side, right? So in this example, what were the two languages there? PHP and JavaScript, right? So you essentially have the same code in two different languages living in two different places that are checking should be the same thing. So this is actually a whole nother problem of making sure your validation is consistent between the two, right? And it's actually one of the big selling points in some sense of running like Node.js everything on the server, because you can set it up so that the function is the same that checks, right? And on the server and the client, it's the same language and the same function, the same code. Okay. So all this was great. We can do fancy animations, all this cool stuff, but fundamentally, right, we're limited. We don't make a request to the server until the user either clicks a link or fills out a form based on everything we've seen so far, right? So our JavaScript code can alter the page however we want, but we still have to make a trip to the server. So this is where the X in Ajax comes in, the XMLHttpRequest Object. So it's actually really funny if nobody realized, actually Microsoft, we have Microsoft to thank for coming up with this. So in the 2000s, Outlook Web Access, so anybody access the Outlook ASU things, was it Exchange 2010, .asu.edu? Yeah, right? So that's, actually looks like Outlook, but it's actually the web front end for the Exchange server. And actually, so I have a buddy who works on that team. By a weird historical accident, like that team is technically on the Exchange team, even though they're emulated, they have the look and feel of the Outlook browser. Like that's actually a different team. So, anyway, it's very weird. And so yeah, so we have this example here that you can go check it out if you've never seen it before. And so the idea was, well, when you're developing a web mail client, right, every mail you click on requires a whole round trip to the server to get that mail. And then when you want to go back to your inbox, there's a whole round trip to get your inbox. And so it actually leads to scalability problems with traditional web applications. You're constantly clicking through things, you know, I don't know about you, but I'm constantly looking at a lot of email when I go through my emails, and if all this required round trips to the server, it could be a problem. So the idea was they created an ActiveX control in about 1998, which would fetch bits of data from the server. So the idea is, well, when the user clicks on their mail in their inbox, let's just fetch those bits of that mail and then display that to the user, right? And then when they go back, well, they can go back. We already have the inbox. And when they click on a new mail, right, we can make a request there. And so it's actually kind of weird. It was towards the, it's like a great, I think I have the link here. There's a really good like historical document from one of the people involved here. But basically, they were close to feature complete. And they were shipping, so they couldn't shove this into their code, so they had to basically gross and get the MS XML team to include their ActiveX control, which is where the XML comes into XMLHttpRequest. So it actually has nothing really to do with XML. You don't have to you return XML back or anything like that. It's kind of a historical accident. And so it shipped in IE5 in March 1999. And Exchange 2000 was finally reached in November 2000, and the Outlook Web Access used this ActiveX object, and then finally, and then Netscape realized, oh man, this is actually a really cool feature, and they added it in 2000. So the full story is here. It's really interesting, but it's kind of, so what was? Does anyone remember what the first kind of like web application they used, where they were like, whoa, how did they do that? Like it's not. For me, it was, I think Google Maps, I think was probably one of the first ones of like, it's not a Flash application, right? But you're like scrolling, you can like infinitely scroll, nothing's refreshing, right? Gmail was also, I think, one of probably the first ones that was like, whoa, how are they actually doing this? So it's actually because of this, so because of all the stuff that Microsoft did, getting this, creating this. So the idea is this object allows JavaScript code to retrieve data from the server, process the data, and update the DOM, all without refreshing the page. And so, once again, browsers, historical differences. In most browsers, you create an XMLHttpRequest just by creating a new object here. In Internet Explorer, you have to use this ActiveX control to actually do that. And so the idea is that onreadystatechange property of this object, you can set actions and JavaScript functions that occur at each point in the life cycle of this request. So part of the idea is, well, and this goes back to something that's in parentheses here, right? So we have the JavaScript code on the page, but if the browser and the page stops everything to go make this request, well then you've lost the interactive component of your application. Then the user can't interact with your application. So the idea is you want this to happen asynchronously. Say, hey, go make this request, and then when something good happens, execute this code in order to update the page. So this onReadyStateChange is a function that gets called, and And so you set up this callback that says, hey, call this function when the state changes. Then you can execute the request to say, hey, make a GET request to this example, and this parameter will say what kind of request you want. And then you can finally send the request. So the third parameter indicates you can actually do asynchronous or synchronous requests. Asynchronous requests are much more common. And so the idea is the onReadyStateChange will get called, and it gets passed a value in here that says, that tells you where it is in the life cycle. So either it's uninitialized, it's actually made the connection, it's loading the data, it is loaded, it's finished loading, and then it's interacted. And finally it's complete where the object is actually finished initialized. So usually wait until the status is complete. So you say if HTTP request ready state is 4, then operate on your data. So finally, once we've received the document, we've checked for a successful return code, the content of the request we can access with our object.response text. This will give us the raw text of the response. We can use the library to parse it as XML, so we can actually have it automatically do that. In this case, we can operate and manipulate this object just through the DOM elements. Okay, let's quickly go through an example. So here's some code. Here's the HTML of the page. We have this insert here element just like we had before. Here we're gonna, so this is actually kind of the raw code. So this we're doing some kind of feature detection of the JavaScript to say, hey, if there's an XMLHttpRequest object, then create a variable called XMLHttpRequest. Otherwise, this means we have to use Microsoft's ActiveX control. If we have a console, if we don't have a console, then set up a log function to call alerts. So this should show you all the crazy stuff you have to do to actually program across the browser. Then we can set up the onReadyStateChange function to log that, hey, this is the ready state, and if the ready state is 4, get the response back, create a new text node, and add that to the insert here div. Then we can say before the request, we get it, we send it, and we say we're after the request. So on a modern browser, so you can see here I'm debugging, I'm at this console.log before request. I'm now logged the before request. I'm opening the request, and actually right after it does this open request, it actually asynchronously calls this with 1 to say it's in ready state 1. Then it does the after request, and then it's in ready state 2. And then it's in ready state 3, ready state 4, and then finally it changes the content of the page to put the test Ajax response here. And we can see if we switch over to the network tab here, we can see that it's made a request to this ajax_test.txt, right? And which was the URL that we gave in our example. So it's done this without the browser changing, refreshing, or anything. And so we can see that that is the value of ajax_test.txt. Crazy enough is this code that we wrote still runs exactly the same in Internet Explorer 6. So we can use Internet Explorer 6, we can go to the same page. We don't have a console to log things to, so this is why we made that hook to create that console object. So this log function actually just alerts. So it says right at the before request, it says we've hit ready state 1, ready state 2, ready state 3, ready state 4, and finally it updates it with the test Ajax. So all this stuff happens automatically in the background. And then it does the after request, which is super weird. I don't know exactly why. But it does work, and just to prove it, this is IE6. Which one does it have? From 1985 to 2004. Wow, that's shocking. Cool. And then looking at this with jQuery, it's like this. You say get ajax test.txt, and when this returns, in the insert here div, insert the data as HTML. I don't have to do any of that crazy complicated stuff where I was testing all these stuff. jQuery does everything for me. And so we can do that, and it just works. It's awesome. And that actually still works in Internet Explorer 6, which is why you want to use something like jQuery. Okay, cool. All right, we'll stop here.